This is 5A on the percent composition worksheet. It says calculate the percentage of water in each of the following hydrates. Hydrates just mean that there's water as part of the formula. Like here is a hydrate, here is a hydrate, and here they're just expecting you to write the formula yourself. So strontium is right here on the periodic table, +2 charge, and chlorine is right here with a -1 charge. So strontium, again, +2, chlorine, -1. So when I write a formula from a name, writing a formula, I need the charges to equal 0 when I add them together. That means I need to multiply the chlorine by 2 in order to make +2 and -2 equal 0. So my formula becomes SrCl2. Now the hydrate part, hexahydrate, that means I have 6 waters. The hexa stands for the number 6, and then hydrate is H2O. So there's my formula, and I'm going to perform a percent composition problem on this analysis, I guess, on this formula to find out just the percent composition of the water. So first I need to do like the formula mass of the entire thing. So strontium, if I go back down to my periodic table and look at the formula mass, this one says 87.62. Again, if you are using a different periodic table, it might say something different. That's okay. Use every number available to you on the periodic table, and your numbers might be slightly off from my answer. That's okay. If they're off by like 3, 4, 5, that's a problem. But if it's like off by 100th or 1,000th, that's okay. I have 2 chlorines. Let's see. Hydrogen is next, 1.0079, and I have 12 hydrogen, right? I have 2 hydrogens 6 times, so that's 12 hydrogen. And then the last one is oxygen, which on here it says 15.999, and I have 6 oxygen. So I'm going to go ahead and multiply those out and then add them up. So this next one, 70.906. This next one, 12.0948. And this last one is 95994. So then I'm going to go ahead and add those all up, and I get 266.6148. Okay, so that's the molar mass of the entire compound. Since I'm finding the percent composition of just the water, right, it asked for the water in each of the hydrates. So here's my mass for the water. So I'm going to add those two up individually. And so when I add those up, I get 108.0348. So that's the mass of my water. I'm going to divide that by the mass of the entire compound and then multiply by 100 to get a percent, right? It asked for a percent composition. And I get 40.5, that's a 5, 2% water. So that's my answer. That's 5. Sorry guys, that came out really bad. 40.52. There we go. 45.52% water. On your quiz, I did say round your percentages to the hundredths place. If you guys want to do that on your homework, you can too. We weren't actually given any sig figs in our problem, which is why we're just using as many numbers as we can in molar mass, and why I'm asking you to round to at least the hundredths place on your homework. But that's it. So when you're finding the water, I guess the difference here between regular percent composition, right? Regular percent composition, if I asked you to do the percent composition for every element, you would take the element and divide by the total to get the percent. You would take each element, but since it's asking for the water, you're taking the total water mass and dividing that by the total mass of the whole compound, and then multiplying that by 100, figuring out how much of this, like what percentage of that is water. So 40.52 is our answer. Let me know if you have any more questions.